Alright, so this is the second part of our Dockerfile video. In the previous one, we went through the basics of the Dockerfile. I explained the layering and the caching so that you know when you're working with the Dockerfile, you know how to plan for your Dockerfile activities and Docker image building. In this video, we are going to build a few Docker images together. And first, I will show you my work process, so how I build Docker files. And it's really not so complicated. Let's open up a text editor and I show you my very simple basic steps for the Docker file, like steps.txt. Okay, so the first step is pick the right image. This is very important. I will show you one example that I built last week. I was playing around with machine learning, and I show you why it's important to pick the right starting image for your Docker file and your Docker images. And the next step that I do, this is a sort of a trick and tip that I want to give you. So once I have picked the right image, and it takes a while because I try various different images. So once I've got the right base image that I want to start from, then I go to shell. So I run basically that image. I open up a container and open up a shell in that container, and I start building my environment. The point is, with every Docker file, that what you're essentially doing, you are building an environment. So the skills and the knowledge that you need is basically an environment building knowledge and infrastructure building knowledge. You are doing infrastructure work. So you have to be familiar with your subject matter. If you are setting up a web server, you have to know how to configure that web server. So that knowledge is something that you have to have. So if you don't have it, then I think you should ask somebody who has that knowledge, or you have to go after that and understand how to configure that specific technology that you're working with. And the good thing is that if you go to a shell, go inside, then you will understand what's inside of your base image and what are the steps that you need to add. And once you got that, then you basically add the steps to your Docker file on the fly. Like you go back and forth between your shell and your Docker file, so you add steps. And yeah, what I do, I just repeat 2 and 3 until I'm happy. So this is, of course, not a very scientific approach. It's basically a try and fail approach, but it's very useful, and especially using the shell saves you a lot of time, because you are not writing into the Docker file directly and then start running the Docker file, building the Docker file, and see the failures, but you will see the failures on the fly. So right now I'm gonna give you one example for the first step that I think is a good example. Is gonna be with Python and some machine learning libraries, especially Numpy, and we will see how to pick the right image for that. And then we're gonna build a PHP image that has Composer installed, and then we're gonna run a web server with Composer, and we're gonna set up the first HTML page that we will serve with that server. And then in the next one, I will show you how to create a Node.js server as well. So we're gonna build these images with Dockerfile. These are gonna be custom images. So let's go to the first one, picking the right image. So let me show you what I found out last week. So if you go to my Docker images, so what I wanted to do, I wanted to play with Python machine learning, and I started creating a Docker image for that. And especially I was trying to install Numpy, which is one of the packages in Python that is used for machine learning and for a lot of other purposes as well, of course. So I said, okay, I want to build my own image that has Numpy installed. And I said, okay, so where is the right image that I should be starting from? And the first step that I took, I went to the Docker store. So Docker store. And I said, okay, I need Python, so let's look at the Python images. And immediately the first thing that I see Anaconda here. If you don't know Anaconda, then I tell you that this is something that I am also using. It has a lot of packages installed, including Numpy. So this would be one option. And another option is, of course, to install Python here, which is the second part. So I was thinking, okay, I'm gonna use one of these two images. I made some more research, of course. I was reading some sites and so on. I looked at some recommendations on Stack Overflow and so on, but essentially the two main options are Anaconda and Python. So I said, okay, let's start with Python and see what we can do with the official Python image. And then if I look at this, I have worked with Python before, so I know that there is a version 2.7 something and there is a version 3. something. So these are two main versions of Python that coexist. And I decided that I want to go with the latest version that is available, so that is 3.6.1. And I see that there are actually a couple of different options here. So there is one, let me show you the big one, the main one here. This one that doesn't have any other tag other than the version number. This one is based on Debian Jessie. Yeah, if you look at the Dockerfile, you see this is based on Jessie. And the other one is based on Alpine. So what is the difference? This Alpine is a very small Linux distribution, while Jessie is a full-blown, full-featured distribution. So I thought, well, maybe Debian has more of the libraries and packages, Linux packages that I need, so it will be probably easier to build with Debian. But then I said, okay, but if I go with Alpine, I'll be able to save a lot of space and I will be more lean and more effective because I will only add those libraries and those packages that are really needed. So I said, I'm gonna pull both of these to my local computer and I will see how to start the work out of these two packages. So let me show that to you. So what I have already pulled them because I don't want to waste time on this just pulling the stuff. So if you, as you look at here, I have, this is the Debian package, almost 600 megabytes, 700 megabytes, sorry. And the other one, the Alpine, is like 88 meg. So you see there's a significant difference in the size. So what's the next step then? The next step is open up the shell and start playing. So then we just go docker run, we remove the container after it's closed, and TI is the interactivity that you probably already know, Python, and I'm supposed to be having autocomplete, but right now it comes with Z shell, but right now somehow it's not working. So anyway, let's do the Debian version first. So bin bash. So I'm inside the shell of this image. I have started a container. I'm in the shell. So if I go python -- version, then I see that there is a Python 3.6.1. So exactly the same thing is installed. So that's fine. Pip is the package manager for Python. You don't need to know this. It's, you know, the point is how we build our image. It's not like understanding Python too much. So anyway, pip is the manager that we use to install Python packages. That's all you need to know for now. So pip is there. So if I go pip install Numpy, then look what happens. It seems to be okay. There's a progress bar. It started installing. So if I want to work with Numpy in the Debian image, then I can very simply just say pip install Numpy, you see, and it's installed. So I could install that, it's ready to go. So right now what I could do, actually I could create a new Dockerfile and yeah, maybe let's make a directory here. Python tut. Okay. Okay, so what I could do for the specific use case, I can create a Dockerfile and say that this is the Python image to start from, and then I could say run, and what have we done? Pip install Numpy, and that's it. Now this is a new Docker image that we created, and it has Numpy installed. We can give it a name, we can build it, and then we have our custom image ready to go. So okay. So let's see, okay, that means that now we created one based on the Debian version, so that means that it's gonna be huge, it's gonna have a lot of stuff installed. So let's try what happens if I'm not using this big one, but I'm using this small one, the Alpine version. So let's say that I go docker run, first, okay, let me say docker images, docker run rmti, and then Python 361, and then Alpine. Now this is gonna be more interesting. Sorry, this is running okay, bin shell. Now it's better. Okay, so right now I'm in the shell and I want to see what's happening. So I go Python version, and yeah, it's there. Pip version, it's there. Okay, so now I go, let's try the same thing, pip install numpy, and look what's happening. It's collecting again, which this looks good, and then installing, and bang, we got an error. What's happening? So it says broken toolchain cannot link a simple C program. So what's happening? What's happening is, okay, what are you supposed, there's an error, of course, because what's happening is that Alpine doesn't have some Linux packages that are required to install NumPy to build this package. And yeah, what you usually do then, you go to Google, of course, you search for this stuff, and then, okay, you look at this and try to find some solution here. Actually, I've been here before, but it doesn't contain the solution, but I know the solution. So anyway, you look through this stuff and understand what you need to do. Or if you are experienced, you already know what you need to do. And what you need to do is basically update the Linux package manager in Alpine first of all, and then we're gonna add the build base package. So add build base and with a dash. Okay, so what's happening now, we install all the packages into Alpine that lets us install NumPy in the end. So that means that let's play the back and forth. Okay, so let's modify this Dockerfile. So I'm starting from Alpine. What we need to do first, we need to run apk update and then add build base. So that's how I go back and forth. I say, okay, I'm starting from the Alpine package or Alpine image version, and then I need to run these to be able to build. And so far these are gonna be the steps, but I'm not really sure if it's gonna work because we haven't tried. So let's go back right now. Build base is installed. So let's try again to install NumPy. And it's not gonna be working, by the way, because we need one more step. So let's wait and see. Okay, so now you see that we have the error. So the error is here, and what's happening now, this is the error message. So again, let's go back to our friend Google and see what's going on. So the Alpine forums, you will find that this is the solution. So we need to create a symbolic link between these two header files. So let's try and do this. I will run this inside my container. It doesn't say anything, so let's suppose that it was working, and let's start installing NumPy again. But before we do that, let's just take a note here that we did this, okay, so that we keep everything up to date and in sync. So let's see what's happening to the installation now. The installation has completed. It took ages, and I don't know if I'm gonna finally cut this part or speed it up, but you will see you will see the final result. So it took like, I don't know, I can't even guess, like 5 minutes or even more. And so you could clearly see that Alpine takes longer and it requires more effort. And our Dockerfile is a bit more complicated. There are 2 additional lines. And the thing is that this is only one package. So if I'm adding another package here, SciPy for example, then things are gonna get more and more messy as we go on. So right now my thinking is that working with Debian is much easier for me because I don't want to spend much time on the environment itself. I want to play around with machine learning, so Debian is a better choice for me. You know, if I would be working on a production system, then I would say let's have a professional approach and really build what we need. And for that, Alpine would be a good starting point, and we would go one by one and, you know, really detailed and sophisticated planning and execution and so on. Or maybe we would just go with Debian anyway because it is more full featured. So this was one option that we understood from the Docker store. As I said, we can use Python or we can use Anaconda. So we had a look at Python, both of the Python versions now, and what I would do, what I also did last week, and then I had a look at the Anaconda versions as well. And well, the documentation here is not so really outstanding because it doesn't really give you too much information on what's going on. But anyway, I have done my homework and I will show it to you because there are some more considerations here. So if I go Docker images, then let's see, these are the Anaconda versions. So there is one version called MiniConda and there is another one called Anaconda. And what's the difference is the size. So MiniConda contains the entire framework and package management, but it doesn't contain the packages. And Anaconda is full blown, and you see the size that is over 2 gigabytes. So this is a Python distribution that has all the packages that you need for most of the machine learning tasks and most of AI and a lot of stuff. So I have used, in my hobby project, I used MiniConda and I added the packages that I needed. So this is the one that you see here. And I ended up with a 2.1 gigabyte image, which is almost the same as having the full-blown image here. So I didn't really save much space or much effort. So basically I think that this was not really worth my time. I could have just gone with Anaconda and don't care. And yeah, going with MiniConda or Anaconda works the same way. So let's see, let me give you just a little insight into that. So let's say, let's run the shell inside. So let's go into Docker run, move ti. Let's go into MiniConda and then say bin bash. Okay, and then we say conda list. And conda list lists the packages that are installed. So this is the number of packages installed by default. Then I say conda install numpy, and then the package with conda is basically fetching numpy and it's going to install numpy here. Yeah, I gotta say yes. So you know, I can bypass this with a flag of -y in the installation. So then I could go to my Dockerfile and say MiniConda, and I could say just like conda, let's say conda install numpy, let's go -y. So that's, you know, that's the stuff that I could do. This is another option that I have. And the installation is going pretty well. It's going to install with no issues. So this is another option that I have. So instead of starting from Linux, starting from an operating system, I'm starting from a pre-configured ecosystem for Python. I can even stop that. Let's not wait anymore because I've been waiting enough. So let's leave this and let's look into the other one as well, okay? Just for the sake of a complete picture. Okay, what have I done? Yeah, a missing run. Okay, and now I can say conda list. So this lists the packages, and you remember the package list that we saw before in MiniConda. Now in Anaconda, you see this list is much longer. So there's a lot of stuff included, and we're gonna find Numpy here in a minute. It's here as well, so it's already installed. I don't need to do anything. And matplotlib, for example, that I'm also using, is installed here. And yeah, the science, where is this? SciPy, Scikit, these guys are also here. So a lot of stuff is already included. So what is the conclusion? That I have tried various base images, and some of them required more work, some of them required less work. Then I tried a couple of them, and I have actually given up on the Alpine image because I was able to install Numpy, but then for other packages I had to do such modifications that I was really not willing to do. I had to download files, copy them inside the image, and then build them and all this. I don't want to do all this. So it was working on Debian just by default. So I left the Alpine version out of the picture, and then I said, okay, so why not go with Conda, because Conda has everything that I need. And I chose to have MiniConda. Then I added all my stuff, and I'm actually almost the same size as Anaconda, so I would probably remove all these Python and MiniConda and stay with Anaconda. That's going to be the final solution. And I will also remove this guy here because this is too much. So my work process is fairly simple. What's your takeaway? It is worthwhile to look at different images, to pull them from the Docker store and play with them, try to build with those guys and see what's in them, which is the most beneficial, the most efficient for you, or the most complete, or the best base. And then go to the shell, play step by step, add your step to your Dockerfile, then go back and forth, repeat this process, and finally you will end up with a Dockerfile. What I learned, throughout my life, that if you have a clear definition that you can repeat again and again, like the Dockerfile is a clear definition that's repeatable and it's always giving the same results, you should look for a solution like that. So you should be always working on something that you can repeat and run that with the same results again and again. So my suggestion would be to play with the shell, make notes in your Dockerfile, and build it again and again and again, and create something that you can go through and build anytime you need a solution for a certain problem. So this is the work process that I have. So now we have closed another big portion of the Dockerfile tutorial, and the next step will be that we're gonna build a PHP image, and we're gonna run a Slim framework, a server inside that image.